Yeah, exactly. All right, we're going to start chapter 4 today. We're just going to look at translations, how we take a figure and translate it specifically within a coordinate plane. Okay, so on page 1, we're just going to fill in a few blanks here before we get started. A translation, let me switch colors.
Can I say something to the people real quick?
No. Okay, a translation is a function that moves a figure in some way to produce a new figure called an image. The original figure is called a pre-image. One thing we need to know about translations is that a translation moves every point of a figure the same distance in the same direction. So we have an example here. Our pre-image is triangle ABC. The arrow between them, this means moves onto. And then we call it A prime, B prime, C prime. So this little mark over here means prime. So every time it's going to give us a pre-image, which we call ABC or ABCD, whatever it is, the new image is called prime. All right? So we're just going to talk through a couple examples, talk about how this works specifically with ordered pairs, and then we'll go from there. Okay? All right. So here, our pre-image would be on the left side, or sorry, the right side. Right? How do I know that this one is the pre-image?
It doesn't have prime.
Yes, it doesn't have prime. Okay? And then on the left side would be my image. And I know that because each of those have the little markings A prime, B prime, C prime. Okay? Now, here's what I need to do. When I'm looking at this, I need to figure out how did I get point A from being here to over here?
Negative.
And you could just tell me like left, right, up, down.
Left.
So,
2.
how many did I go to the left?
4.
3. Shoot, I don't know. I can't see.
6.
Okay, well, you guys have it right in front of you. So, look at your paper instead of the board. So we start at A, and I just count 6 over till I'm underneath A prime, right? So we went left 6
Up 2.
and up 2. Now, I know when we've been graphing, right, we've been using slope-intercept form, and in slope-intercept form, we use rise over run. So we move up and down first, then left and right. But anytime we graph ordered pairs, what direction do we move first? Left or right, the x value. Then we move up and down for the y value, okay? So you are going to have to keep that straight when we kind of start talking about this, is we'll move left and right first for x, up and down for y. Yes, Rowdy?
So whenever we're like explaining it, is it just gonna be like plain speech? Like we're just gonna say like however many which way and
Sometimes, yes. Sometimes we'll say like the points move left 6, up 2. Other times, which I'm about to show you, like when we write a rule, we'll use what's happening to x, what's happening to y. Okay? So our translation rule, the original ordered pair was xy. My new rule, so if I move left 6, what would I do to the x value?
Plus 6.
Moving left would add 6?
Negative.
Yeah, it would subtract 6, Turner. So I would say x minus 6. Ooh, sorry. And then for my y value, if I'm moving up 2, would be y plus 2. So when we write a rule, Rowdy, we write it like this. We show either subtraction or addition to the x and y value. Okay? Not too bad. All right, let's look at example 2. Who can tell me which one is the pre-image? Left or right?
But
Left, right? Oh. I'm writing what I'm saying, not what I'm... So pre-image is here. My new image is here, and I know because they say A prime, B prime, C prime. Okay? So, again, it doesn't matter which point you use. You could use A, B, or C. Excuse me. Let's use B. So, how many left or right would I move first for B?
9 to the right.
Say that again.
9 to the right.
Good. So we're going to go right 9. And then up or down?
Down
How many?
7.
Down 7. Everybody see how we're getting that? So we start at B, count right 9, then we go down 7. Okay? So, can anyone tell me then what would be my translation rule for X and Y?
X, y goes into x plus 9,
Good?
y minus 7.
Perfect. Because here's the deal. Sometimes we won't have a graph, right? And it'll just tell us we're going to find A prime, B prime, C prime by doing this. Adding 9 to our X values, subtracting 7 from the Y values. Okay? All right, let's look at the back page. So, back page is what I was just talking about. Now, let's do this first. Let's go ahead and plot the original points it gives us, our pre-image. I'm going to do that. If you have different colors and want to use those, sometimes that's helpful. If you don't, that's okay, because we're going to label them anyway. All right? So I'm going to use blue. P is at 1, negative 2. Q is at 2, 1. R is at 4, 1. S is at 4, negative 2. And then we do connect those together.
Yay. It's like connected up.
Okay, so here we have our pre-image. Now we're going to graph and translate our new image. How do I find my new ordered pair?
X is you don't move.
So X stays the same. So for P, I'm still going to have, we're going to write P prime. So what's my X value for P prime?
1.
Still going to be 1. How do I find the Y value?
Add minus negative.
Subtract 3. So what's negative 2 minus 3?
Negative 5.
Negative 5. Okay? So it says for the Y value, we subtract 3. My Y value was negative 2. I subtracted 3 from that to get negative 5.
So you leave the Y the same.
Not the Y, the X, right? Because notice X doesn't have any rule with it. It just says it's going to stay X. Okay? All right. Kaylee, can you tell me what Q prime would be?
Your X is 2,
Okay.
and Y is 2.
Close.
Is it -2?
Negative 2. Yep. Because 1 minus 3 would take us to a negative. Okay. Caden, what about R prime?
4.
4 for my X.
Negative 2.
Negative 2 for my Y.
The same point as S.
Okay. Do what?
Oh, I'm like plotting it down here.
Jordy, do you know the last one? Did you say 4? Okay. And then negative 2 minus 3 would give you negative. Close.
What's it right there?
It's negative 2 minus 3.
1. What's the 1?
That would be plus 3. Remember, subtracting, we go further negative. When you have two negatives, add and keep the sign. Okay, good. So every x value stays the same. Every y value just moves down 3. Okay, so now we can put those points on there. So we have 1, -5 for P. 2, -2 P prime for Q prime. 4, -2 for R prime. And 4, -5 for S prime. Okay. All right, let's look at one more example of this, and then we'll look at composition, and we'll be done with this part today. Okay.
You're not gonna sleep.
Not quite. We have one more thing to do. Okay.
That was an evil smile.
Well. All right. Example 4. We're going to translate the figure xy to x plus 1, y plus 4. So what are we going to be doing to each x value
Adding 1,
and to each y value?
adding 4.
Good. Okay. Our original will be in blue. Our pre-image. T is at -1, -2. U is at 3, -1. R is at 0, 2. And -5, +2 for S.
That's a big shape.
Yeah. Okay. Anybody want to take T prime?
0, 2.
Rowdy? Well, I'll give you the next one, Rowdy, since someone already answered.
I made it.
Okay, tell me how you got 0, 2.
-1 plus 1 is 0.
Good.
-2 plus 4 is 2.
Okay, let's go and graph that. 0, 2 is going to be T prime. All right, Rowdy, U prime.
It's 4, 3.
Good. Okay, somebody want to do R prime?
1, 6.
And S prime. Anybody?
-4 is 6.
-4, 6. Okay, then we're just connecting those together. Good. Okay. Simple enough for this, yes? All right, last part, we're going to talk about performing a composition. So a composition is when two or more transformations are combined to form a single transformation, okay? So in our example, it says graph RS with the endpoints of R and S and its image after the composition. So let's start with RS. R is located at -8, which notice here we just have a negative and a positive on our axis. So -8, 1, 2, 3, 4, 5, 6. +5. And then -6, +8 would be here. So we have two translations to do. What is our first translation doing to each value?
Adding
Good. So we start for r at negative 8, 5. What is r prime going to be? What's negative 8 plus 5? Negative 3. 5 minus 2? Positive 3. Good. Okay, and then for s, we started with negative 6, 8. So for s prime, we're going to do negative 6 plus 5, negative 1. What about 8 minus 2? 6. Okay, I'm going to change and put that in red. So negative 6, we're going negative 3 and up 3. This will be r prime, and then negative 1, positive 6 for s prime. Okay, then our next translation, we're going to take r prime. So r prime was what ordered pair? We wrote negative 3, 3. And now we're going to find r double prime by subtracting 4 from that. So what is negative 3 minus 4? Negative 7. And what about 3 minus 2? 1. Okay, same thing with s. We're going to take s prime, which was negative 1, 6, and find s double prime. Negative 1 minus 4. Negative 5. And 6 minus 2. 4. And then we just plot those points. So negative 7 would be here. Up 1. And then negative 5, 4.
So is double prime just the second?
It's just it's just a second translation of prime.
So can that be like 3 of them? Can it be like double prime?
It probably is possible. Yeah, I don't think we'll actually look at any of those. I think 2 will be the most we'll do, but I mean, yes, it is possible. You could translate double prime to triple. Sure. Okay. We're okay with this, yeah? Okay. All right. You can put your notes up.